So, as we were discussing, last week about different forecasting method for population. Now, the last which we discussed was decreasing rate of growth method, and in today's class we'll be discussing another one graphical method, that is comparative graphical method. This method is very interesting because this requires some analytical mind to get the best possible prediction or forecasting. Hope all of you are able to hear me and see my screen.
Yes, sir.
Okay, thank you. So, what is comparative graphical method? So, as the name suggests, here we have the provision to compare something which is of similar, features, or which is of similar characteristics. So, in this method, the cities having conditions and characteristics similar to the city whose future population is to be estimated are first of all selected. Now, it is then assumed that the city under consideration will develop as the selected similar cities have developed in the past. So, we are trying to trend the rate of development similar to some other cities. So, that is where the question of comparison comes into the picture. This method has a logical background, and if statistics of development of similar cities are available, you can forecast population quite precisely, and the results are also reliable since it is based on the practical data which you have obtained from the similar cities within the country itself. So what we do in this case in comparative graphical method, so we basically so the curve of past population of the city under consideration is plotted on a graph, and the curve is extended carefully by comparing with the population curve of some similar cities. So that is the methodology of doing this. And the main advantage of this method is that the future population can be predicted from the present population even in the absence of some of the past census report. So that is where the main advantage of comparative graphical method uh, should be considered. In previous forecasting methods, whatever we have discussed, we had to obtain the population census report or previous few decades, not only one, two, we needed at least 4 to 5 census report or previous decades. However, in this case, even if we don't get that many census report, the last decade census report would be sufficient for our purpose. Now, this method can further be explained, by the help of a problem. So let me first show you the problem. So if you see here, what we are actually telling is this is an example, and if I discuss with an example, it will be much more, easier for you people to understand. So the populations of a new city, which can be denoted as X, given for few decades, let's say 70, 80, 90, and 2000, and we have given the corresponding population respectively. Now the cities A, B, C, D were developed in similar condition as that of city X. Right? It is required to estimate the population of the city X in the year 2010 and 2020. The population of cities A, B, C, D of different decades were given below. So in the problem itself, the population, since the census report has been given over here for the previous decades, and it's same 60, 70, 80, and 90. You can see the population and the change in population with respect to decade for city A, B, C, D. So that is the overall problem which we, and at the same time, so what we need to do here now, let me show you. Yeah, so we'll have to plot, as I was talking about, in the previous slide while talking about the methodology. So what we do in this case is, population curves for cities A, B, C, D, and X are plotted. So subsequently, for all 5 cities, should be plotted on a single piece of graph. And what you can see here is the population curve X is extended beyond 50,000, matching with the dotted mean curve. Fine. So an average mean curve is also plotted by dotted line, as you can see in the figure. So that is the average mean curve. Now, once you extend the population curve for the city X, you should follow the same kind of curvature and same kind of trend to extend that population curve further. And from the curve, then you can obtain the populations of the city X for 2010 and 2020, and that comes as 58,000 and 68,000 respectively. So this is the overall process by which we can utilize the comparative graph method. This is a very, very logical method, and it's a simple method. It has some inherent advantages, and that is why, as far as practical point of view, this particular method is very useful and very efficient, that we can say. Now, coming to the next one, that is the master plan method. So this master plan method is basically, it is named as zoning method also. So what is done in this case, big and metropolitan cities are generally not allowed to develop in haphazard and natural ways, but are allowed to develop only in the planned ways. Fine. So what happens is, the expansion of such cities are regulated by various bylaws, or corporations or other municipal authorities or any other local bodies. So they basically monitor the expansion of those big cities, and only those expansions are allowed which are permitted or proposed in the master plan of the city. So if it is not there in the master plan, it won't be allowed to expand. So that is the basic idea behind master plan. So the master plan prepared for a city is generally such as to divide the city in various zones, and thus to separate the residents, commerce, and industry from each other. Fine. So the population densities are fixed for various zones in the master plan. From this population density, what total water demand and wastewater generation for that zone can be worked out. By this method, it is very easy to assess precisely the design population. Fine. So, if I would have to give an example, so there, let us assume that there may be 5 persons living in the residential plot, and there may be 10,000 plots in a zone. Fine. Then the total population of this zone, when fully developed, can be easily worked out as 50,000. Hence, when the development is regulated by such a scheme, it is very easy to assess precisely the design population, because the master plan will give us as to when and where the given number of houses, industries, and commercial establishments would be developed, and depending upon that, you can get the maximum. You can get the population in the next decade and next to next decade. So everything is planned, way before then. It should be constructed, and that is why you have all the data, and from that data itself, you would be able to forecast the population. So this is one of the very efficient method in terms of practical applicabilities. Next come logistic curve method. So this method, if you see and if you can remember, which we discussed in the previous class while talking about the change in the population with respect to time for a particular city, we showed some graph over there, and we mentioned that in the first the rate of increase is huge, and then there will be a straight line, and then after that the rate of increment will be in the decrease state. So if you can remember that logistic curve, so from that this particular method has been developed. So basically logistic curve method, this method is used when the growth rate of population due to birth, deaths, and migrations takes place under normal situations, and it is not subjected to any extraordinary changes like epidemic, where earthquake, or any natural disaster, or any huge immigration because of some political issues. So when those things are not there and the population follows the growth curve characteristics of the living things within the limited space and economic opportunity, then logistic curve method can be applied. Now, if the population of a city is plotted with respect to time, the curve so obtained under normal condition looks like a set curve and is known as the logistic curve, which we actually showed in the few class back. Just let me show you again. So this is the graph actually I was talking about, and we have the point of inflection where this B point is known as the point of this C point is known as the point of inflection. So that is actually assume the midpoint of that apparently straight portion, and then comes the top part DE, where the rate of growth is in the decreasing side. So what is done is we'll go back to the current slides and then we'll explain it. Yeah, so a mathematical solution for this logistic curve, which can be represented by an autocatalytic first order equation, is given by, you can see over here. So this is known as autocatalytic first order equation, and the derivation is also given in the textbook. You can go through that. I am not deriving over here again. So what we need in this case is to understand the different connotations which are being used in this particular autocatalytic first order equation. So capital P stands for population at any time t, then PS is the saturation population, P0 is the population of the city at the starting point, K is the constant, rate constant which we can consider, and then we have the T, that is time in years. Now from the equation we can write the log base E within a bracket PS minus P by P, and P0 by PS minus P0 equals to minus K PST. So here again, if you see, all the connotations are known to us, and based on this equation we can, after solving, what we can get is we can get the value of P, and you can see that equation over here, and PS minus P0 by P0 can be considered as a constant, and which can be denoted as M. Similarly, K into PS would be another one constant which would not have any other influence, so that can be considered as constant and can be denoted as N. So the final equation would become PS by 1 plus M log inverse NT. So this is the required equation of the logistic curve which will be used for predicting populations. And if only three pairs of characteristic values of P0, P1, and P2 at times t equals to 0, t equals to 1, and t equals to 2t1, extending over the past record are chosen, the saturation population can be obtained, and constant M and N can be estimated by the help of the equation over here. So you can see how we are going to get, if we know the value of P0, P1, and P2, and we can then calculate the value of constant M, we can get the value of constant N, and similarly we can get the value of PS. Now once we know all these three values, we would be able to get the value of P, which is the desired one for our case. So this method is quite simple, and if we can apply this formula, we will be able to get that. And the number of data which is required to perform this forecasting method is less, and that is why this method is quite efficient in from that point of view. So now let us discuss one problem, and that would help you people to understand much better this logistic curve method. So this is the problem, and you can write your notebook, and then you can let me know how to solve this problem. First, all of you should write the problem. So the population of a city in 3 consecutive years, that is 1991, 2001, and 2011, is given over here. And now, what we need to determine is PS. What we need to determine the equation of the logistic curve, and then the expected population, that is P 2021. So the best thing is here, you can get the value of T1, you can get the value of T2, and you know the P0, P1, P2. So technically we should be able to get all the values of PS, M, and N, and thereby P 2021. So you should be able to apply what I discussed in the previous, so you can write these formulas first. So first you write the, equation for obtaining P, and then what is M and what is N, and then how to calculate this M and N. And once you have written these, please let me know. I'll go back to the problem. All of you should write this, otherwise you won't be able to remember and you won't be able to work out the problem. So write the equation for P. Is it okay? Can I go to the next slide? Just wait, someone has messaged me, it seems. Okay, so you just tell me, unmuting yourself for a second, because otherwise I would have to come back again and then I'll have to check it. Okay, so in the next slide we have the equation for PS, that is the saturated population, and we have the equation expression for M and N. You can write them, and once you are done, please let me know. Is it okay? Do you write this? Can you go to the next slide?
Yes, sir.
Yeah, so this is the problem. You can write the problem and you can try to solve. If you have any issue, you just let me know. I'll help. Hope all of you had written the problem. So I'll go back to the screen and I'll try to see your answers over here. So first what you should do is you should write which one is P0, which one is T0, P1, P2, T1, T2, all those things. And once you write all of them, then you try to calculate the saturation population, that is PS, by the help of the expression PS equals to 2 P0 P1 P2 minus P1 square into P0 plus P2 by P0 P2 minus P1 square, and then tell me the answer for PS. Yeah, so the PS value is correct, and don't write PS value and P value in decimal, because it cannot be in decimal since it is the number of population. Your M and N can be in decimals, no problem whatsoever with that, but you cannot express PS and P in terms of decimal. So that is why you have to round up to the near, to the next full number. Yeah, so this is correct, Rahul. PS value is correct. So now you calculate M, and then subsequently you calculate N, and finally you calculate population 2021. Yeah, so M and N value is correct, Ankit. Okay, so this is correct. The value of PS is correct. So those who have got the value of P 2021, can you please write it again, because connection was lost and I I don't know how many of you could get the answer. What is the value of P? Yeah, P0 value is correct. Those who have written P0 value is correct. Yeah. Okay. Rahul Kumar, it is correct. So calculate the value of capital P. What about others? All of you should do, and because these answers will be there in my Google Drive, I will be able to see it later on also. So only being present in the class would not help. Try to Engage yourself in the activity. Now, those who could calculate, let me know the value of P. Yeah, PS is correct. Yes, Ankit, the value is correct. Ankit Raj, the value is correct. Now, let us see what others do. Fine, so the value of M is correct. Now you calculate N and then finally you tell me the value of P 2021. This is a simple problem, so you are taking more time than what is required. Yes, so this is correct. Archit, this is correct, yeah. Yeah, fine. So I guess we can go to the next. This exact mark, this is correct. So just ensure me that none of you are having any issues with any of the forecasting method, whatever we have discussed. So we'll go to the next chapter. So before that, I would like to know if any one of you are having any problem in the current chapter which we have discussed. Any problem, or should we move to the next chapter and I will just introduce that chapter to you people. Is that okay? Any questions from this particular chapter, whatever we have discussed since the beginning? Okay, so since there is no response, that means that you don't have any problem, so we can go with the next chapter. Fine, so yeah, the value of P is correct. Those who have got this value 605436, this is the correct value. So I'll not solve the problem. Most of you could do it, and I have not given response for the any one of you, those who could not solve the problem. So I think that I can assume that all of you have solved the problem and you did not have any problem while solving it. So with this, we'll go to the next chapter. So just hold on for a second. Let me open the next slide and then we'll discuss about it. Are you able to see my screen now? Is it
Yes.
visible? Okay, good,
Yes, sir.
good. So what we are going to do Basically we have talked about water demand, we have talked about supply, and then the immediate one is the quality, and that is what actually we are going to talk about in today's class. So once we say water quality, this is a really holistic view about the characteristics of the water which I'm talking about, and this quality can be altered depending upon on what purpose we are going to use the water. So this is the unit 1 part 2 which we will be discussing in today's class. So once we say that quality of water, and the first point is basically we don't get absolutely pure water, right? In the, if you see anywhere, absolute pure water is never found in nature. Now this absolute pure water is also a qualitative term, you can say that, but then here what we are trying to tell is the water which is consumable. So in the purest form we don't get them, fine. So it would contain some amount of impurities, and with varied concentrations, and that is the main reason of considering quality aspect as very important or integral part of the water supply engineering. So the rainwater, which is, if you try to imagine the overall cycle, hydrological cycle, you would be able to relate it better. So the rainwater, which is originally pure, also absorbs various gases, dust, and other impurities while falling down, and that is why once it precipitates in the form of rainfall, it cannot be called that much pure, because all those impurities have been mixed with the water. This water, when moves on the ground further, it carries salt, different type of organic and inorganic impurities, while surface runoff and as well as percolation. So this water, before supplying to the public, should be treated and purified for the safety of the public health, economy, and the protection of various industrial processes. And it is most essential for the water work engineer to thoroughly check and analyze, and to do the treatment of the raw water obtained from the source before it would be added to the distribution network. So the water supplied to the public should be strictly according to the standards laid down from time to time by the authority and the agencies. Fine. So there are few agencies in the country, and as well as if you see globally, so they basically standardize the quality of water for different purposes, and we have to follow them strictly whatever treatment we are going to adopt. uh, at the end of the treatment, as an outcome, we always would get the value or the impurities and its concentration way less than the permissible one, and that is the main objective of quality assurance policies of the water supply engineering. So if you say here, what we do is we try to the main objectives of the water quality management. So first we can say that collect water from best available sources. So if we have several sources present in the locality, we should be able to figure out which one is the best in terms of quality of water, and as well as which would be which can suffice the demand which has been otherwise calculated after the population forecasting and so on. And depending upon that demand, if that particular source which has purest relatively better or better quality of water can be chosen. So to processing which will ensure water of good physical quality and free from unpleasant taste or odor. So the more or the better quality of water you obtain, lesser would be the time, money, and energy in purifying further that water. So that is the main objective of water quality management. So we should be able to recognize the good physical quality, and which does not have any unpleasant taste and odor. And if we can ensure that we are able to collect that water for our water supply system, that would be most apt and suitable. Moreover, the water containing nothing which might be detrimental to health. So this is very important, since water supply system and public health are quite they are very closely connected with each other, and the entire public health of the society would depend on the quality of water which you supply. And that is why, while choosing a particular water from a source, we have to ensure that it does not contain uh, anything which might be detrimental for the health. Not essential to have chemically pure water, and which is impossible otherwise also, because this chemically pure water has been defined in the previous classes, if you can remember. So we don't need essentially to have or to recognize the chemically pure water, and we have to provide that, because chemically pure water is not good for health also to consume, because when we take water as for our drinking purpose, that water which contains some amount of minerals within the permissible limit, it actually adds in the body, and it helps in the better metabolism of the body. And that is why chemically pure water is not suitable for drinking or for other purposes, and that is why it is not essential also to have chemically pure water. Sometimes presence of some minerals gives good taste of to water, and that is why we say mineral water. And the water which we purchase from the market are basically from different MNC, those who actually manufacture mineral water, packaged drinking water. So basically all those minerals are there within the permissible limit, and that can ensure the better taste of that water. Now, depending largely upon the sources, the various waters so obtained may differ greatly in purity and suitability for the purpose for which they are required. And this is very obvious, what are the different sources, in what way you are going to use that water. And from that point of view, you can basically assess how pure water do you need for that purpose, and then what would be the suitability. At the same time, uh, the quantity of water which you need, that also needs to be checked before choosing a particular source of water. So these are the very important aspect of the water quality management. And when we talk about the objective of water quality management, we basically try to look upon all those aspects, and we try to analyze them to get the best possible water in terms of quality. Now, to ensure safety to the public health, economy, and utility, imperative upon the planners and engineers to manage water quality. Yeah, so many things you need to see. If you can reduce the treatment by getting better quality of water, you can actually save some money, and that would be huge. As far as the uh, government, or the particular agency, government agency, who are actually uh, providing all sorts of water supply scheme. So that is why it is important for the planners and engineers, those who are going to manage the water supply scheme, to keep a very stringent eye over the water quality aspect, and that would ensure safety of the public health and economy together, and that would be much more efficient in terms of overall water quality management. So with this, I stop today, and we'll continue in the next class.